Okay, we're going to take what we have learned about Venn diagrams and apply it in a very mathematically practical way by filling in some information based on what we've been given. So here goes. 57 people ordered a pizza at Pizza Palace on Tuesday evening. 33 ordered a pizza with pepperoni, which is why I put a P here. Go ahead and do that if you need to. 20 ordered a pizza with ham. There's a H. And 5 ordered a pizza with neither. So maybe it was just cheese, maybe it was Canadian bacon, maybe it was hamburger, who knows. But anyway, there you go. We are going to place the appropriate numbers in the Venn diagram. So let's read the problem again and figure out what goes where. But before we do, let me point at the different areas and talk about what they represent. And first of all, this big area right here is all the pizzas that were ordered, or 57 people that ordered a pizza. So the total of every number that you see in this rectangle is going to be 57. So all the numbers added together from all 4 regions are going to be 57. I say 4 regions because here's a region, and this is the region where we don't have pepperoni, we don't have ham. So these are the people that ordered a pizza without pepperoni, without ham. Okay? These people are pepperoni orderers. These people are the ones that ordered ham, and these people are the ones that ordered a pizza that had pepperoni and ham. Okay? So as I look at the totals, and I say 33 ordered a pizza with pepperoni, that is fantastic, but I can't just put 33 here because there's some overlap. This is not necessarily 33, but the total of these two is 33. And then 20 people ordered a pizza with ham. This is 20. That isn't necessarily 20, but the total of these will be 20. And then 5 ordered a pizza with neither. Ha-ha! Wonderful. A place to start. Let's put a 5 right here in the corner. And now that we know how many people ordered a pizza with neither, we can really get started with this. So let's kind of start over. And I'm going to be writing out some very basic mathematical things, but that will help us figure out what we're doing. So 57 people ordered a pizza at Pizza Palace Tuesday evening. Okay, great. 57 people ordered a pizza. 5 of them ordered nothing. Well, let me rephrase it. 5 of them didn't order pepperoni or ham. So 57 people minus 5 people is going to give me 52. And this 52 represents the total of my P and my H together. Let me actually rephrase that using the appropriate mathematical word. This 52 is P union H, or also called P or H. So it's a list of all the pepperoni, all the ham added together, okay? This is going to come in really handy right now. So 33 ordered a pizza with pepperoni. So the total of this whole circle is 33. And if the total of this circle is 33, and you have to follow me closely and look where I'm pointing, this is 33, but the whole double circle area is 52, then if I do 52 minus 33, then I will find out what this region is. Okay, so we're going to do 52 minus 33, and we're going to get 19. And this region right here is the people that ordered a pizza that had pepperoni or ham, but actually didn't have pepperoni. We subtracted away our pepperoni people. Okay? So this is ham only. Okay? This is not written in mathematical format. Technically, this is going to be, well, it's a very complicated way of writing it, but 19 is right here. Let's write it in red because it goes there. Okay? So we're almost done with this. We only have 2 more regions to fill in. Now, again, by the way, when I'm done, I better have this number, and this number add up to be 52. And then this, and this had better add to be 57, or we're wrong, okay? And let me just point out something else one more time. Even though they gave me 33, and that was pepperoni, it actually helped me figure out ham, because I subtracted pepperoni from the total, and it gave me just ham. So ham only. Okay, let's figure out what goes here. And that number right there is 1. And here's why. There are 20 people that ordered a ham. 19 of them ordered just ham. Ham only. Sounds kind of like a Michael Jackson thing. Ham only. So there is one person that ordered pepperoni and ham together. And if you really want to get technical with the way this one is written mathematically, this would be P intersect H. Again, I did not write this one mathematically. Actually, let's do that. Let's write this one using a mathematical statement. This 19 was ham minus pepperoni. Now we're almost done, and we're going to figure out this number right here. Again, when I'm done, this number had better add together with the rest of them to give me 57. That's the total. So almost finished. We can do this one in our head. I'm going to write it anyway in this tiny little space I have down here. 33 ordered a pizza with pepperoni. Well, pepperoni is 33, so 33 minus 1, and of course we can do that in our head. That's 32. So this number right here is 32, and if you want to know the actual mathematical way to write this, this is my pepperoni minus my ham. So if I take all my pepperoni, but I subtract away the ham overlap, then I have 32. Let's double check. 19 plus 1 is 20. 20 plus 32 is 52. That works. There's your 52. 52 plus 5 is 57. Boom, got it. Now let's answer some questions. What percent, oh boy, percent of customers ordered ham or pepperoni, or both actually. So when I say ham or pepperoni, it could be ham, could be pepperoni, but also we're going to count that 1 in there too, because if I ordered ham and pepperoni, then it really counts, right? And we can get into some of the verbiage of what or truly means, and we will in a later lesson. Okay, so what percent of customers ordered ham or pepperoni or both? Well, that would be 32, 1, and 19. We already decided what that was. That was 52. So that's 52 people. 52 people ordered ham or pepperoni or both. And that was out of 57. And when we divide that, we're going to get a decimal. And that decimal can easily be turned into a percent by multiplying by 100. So 52 divided by 57, I got 0.91. I'm rounding it off a little bit. And then we're going to say, well, 91% of our customers that evening, on Tuesday evening, ordered ham or pepperoni. That includes both. Okay, what percent of customers ordered only ham? Only ham, that's 19. So don't count this one. This one is ham and pepperoni. So 19 out of 57. And so 19 out of 57, we'll just type it in the calculator, and we get 0.33. I don't know why I typed that in, because I should know that one. And so 33%, there we go. That's a third. Roughly a third. I did round off. Okay, what percent of customers? I do want to point out the way this is worded. It says what percent of customers. Okay, so that tells me what my denominator is. Like if this would have said what percent of pepperoni people, like then my denominator would not be 57, because I don't have 57 pepperoni people. But if I said what percent of pepperoni people, my denominator would be 33, right? I want to point out that the way it's worded determines what your denominator is. But what percent of customers, that's 57, ordered pepperoni? That'd be 33, not 32, 33. 33 out of 57 is 0.58, and that, move your decimal 2 places, which is the same as multiplying by 100, which is how we deal with percents. That'd be 58%. Okay, we're going to do another one that's very similar to this. So we're going to flip the paper over and keep on moving. Here we go. The 148 literature professors at New Hampshire University, I made this up by the way, were asked their opinions about changing the grading policy, the attendance policy, or both. And here were the results. So we have these data right here. By the way, data is technically plural. The English language has shifted enough to where people can say, here is the data, where it's referring to data as singular, but technically that's not correct. But here are the data. Just throwing that out there. Anyway, let's deal with our Venn diagram, and we chopped off a little bit here, but it basically say either a policy to change. That was the question. So let's label some stuff. We're dealing with the grading policy and the attendance policy, and this, of course, is both. And the total, without me even reading anything, the total of everything I see in this Venn diagram is going to be 148. Okay? 148. So I know I have this region, which is outside the circles, plus this one, plus this one, plus this one. It better be 148, or we've done something wrong. Okay, 47 would like to see the grading policy changed. I'd love to put a 47 right here, but technically it's both of these, and so I don't know how much goes in each one. Okay, 36 would like to see the attendance policy changed. That means 36 is here. No, it's not. It means both of these together make 36, and I don't know how much go in each one. If I knew this number right here, we could do it. We're about to get there. 78 do not want to see either policy changed. There we go. Let's write it in red. Sounds important to me. 78 is outside of grading and attendance. Okay. Place the appropriate numbers in the Venn diagram. We're well on our way. I am not going to write out the things that go through my head on this one, but I am going to be very clear as I go through them. So 148 minus 78, I'm embarrassed that I almost typed that in. That's going to give me 70. So here's what's about to happen. Actually, here goes. I'm going to type it anyway so you can get a visual for it, because I don't want to talk about a number and you not have the visual to see what's happening. Okay, 70. Even though we can do that in our head. 70 is the total of all three of these together. So grading, attendance, all together, 70. Grading, union, attendance is 70 people. So here's what's going to happen. I'm going to point very carefully. 47 would like to see the grading policy changed. This circle is 47. If this circle is 47 and the total of both circles is 70, then 70 minus 47 is going to give me what is not in the grading circle. Okay? So when I press enter and I get 23, then 23 is right here. I know it's right there because, again, this total is 70. And if I subtract grading, then I get only attendance. Okay? We could do the same thing to get this one. I didn't do it that way a minute ago, but I totally could. I could say, well, 70 is the total in here, and I subtract 36. And when I subtract 36, here's 36. This whole thing is 36, which automatically tells me that too, by the way. And when I subtract that, that's going to give me 34. This is 34. Just grading. I didn't do it that way earlier, but here's another way. Let's suppose I don't know this 34, but I do know that this is 36. 36 minus 23. So when I press enter and I get 13, my 13 is going to go right here because I know this whole circle right here is 36. So 13. Now I'm going to double check everything. I better get some correct numbers here. So 78, 34, 13, 23. I better get 148. Okay, cool. 34 and 13 is 47. Sounds good. 13, 23, 36. It's good. 34, 13, 23, 70. We got that earlier. We're good. We're good. Let's keep going. What percent of literature professors, okay, just literature professors, and that is 148. That tells me my denominator. Actually, I'm not even going to do the problems yet. I'm going to go through here and just write some denominators. 148. Let's read the next problem. What percent of literature professors? I have 148 literature professors. Next problem. What percent of literature professors that want to see any change? Whoa. Okay. These people want to see grading change. These people want to see attendance change. And the total of those is 70. Okay? So on number 22, when it says what percent of literature professors that want to see any change, it's all of those. All right, number 23. What percent of literature professors that want to see a change in the attendance policy? That tells me that I'm only dealing with these folks right here. That's 36. All right. Haven't even read the rest of the problem yet, but I know my denominators. Let's go back to number 20. What percent of literature professors do not want either policy to change? That'd be 78 out of 120. We'll deal with that in a minute. What percent of literature professors want to see both policies changed? They want to see grading and attendance changed. That's 13. What percent of literature professors that want to see any change? That's the 70. Would like to see both policies changed. That's 13. Didn't we just do that problem? No. This was 13 out of everybody. This is 13 out of just those that want to see the change. This is where they would like be reading the data to you and say, of all those that want to see a change, 13 out of 70, or, then they'd give you a percent. All right, what percent of literature professors that want to see a change in the attendance policy, 36, would also like to see a change in the grading policy? So basically, who's here that's also here? That'd be 13 out of 36. Let's go ahead and do that one because that one's easy. 13 out of 36 is, I said it was easy. I thought it was going to be like 1/3. It's not. It's almost a little over a third. 13 out of 36 is 0.361111. That's 36%. We are rounding. I'm going to move up here. 13 out of 70. 13 out of 70. Dentists agree. 0.19. 19%. 13 out of 70 dentists agree. 13 out of 148 doctors agree. That sort of thing, okay? So we've narrowed it down a little bit. That's what I was referring to earlier, if that was confusing. This one is 0.09, which is 9%. So 9% of literature professors want to see both policies changed. And 53%, so 0.53, which is 53%, do not want either policy to change. So more than half.